Hello, welcome to the Department of Education Graduation Analysis. Before we begin, I want to introduce our group member to you all. Let's begin with a video specialist, Esther Aquila Solte. Next, we got our word expert, Mohammed Osan Nase. And then we got our data analyst, Danielle Controlis. We got coming up next, our data visualist, Sam Huang, and then lastly, we got our PowerPoint expert, Emily McNally. Our primary objective is to identify the factor that impacts a university undergrad graduation rate in the United States. By doing so, our analysis will provide informative data on the factors affecting undergrad graduation in America. The purpose of this report is to determine the element that affect undergrad graduation rate, offer information that helps university and college, and recommend suggestions to assist schools and universities in raising their rates.
After studying the data from Excel, the variables that we decided to analyze in our regression were type of institution, urbanization type, total applicants, and tuition and fees from 2010 to 2014. For tuition and fees, we decided to take the average across all 4 years and use that in our regression model. For type of institution, we decided to make a dummy variable, making public universities equal 1 and private non-for-profit universities equal 0. For type of urbanization, we decided to make 3 of the types of urbanization dummy variables, which were city, town, and rural. Through our final regression model, the equation that we ended up with was graduation rate equals negative 4.772 plus 13.975 public dummy variable plus 0.0004897 applicants total minus 2.419 city dummy variable plus 1.991 town dummy variable minus 1.5662 rural dummy variable plus 0.0018 average tuition and fees. Through this regression model, we found that all x variables except for the rural dummy variable are significant. The p-values of public dummy variable, applicants total, city dummy variable, town dummy variable, and average tuition and fees are less than the 0.10 significance level, meaning that these variables are significant predictors in the graduation rate.
Next up are the interpretations of the R-squared, standard error, and p-value. So these values allowed us to see which model is the most accurate and reliable, and specifically, we were able to pick that best model by having the highest R-squared and the lowest standard error. So for R-squared, we got 0.617, which means that we're about 62% of the way towards perfectly predicting graduation rate using this model. Next up is standard error, which we got 13.4, which means that our predictions for graduation rate are off on average by about 13%. And then finally our p-value, which we got was 0.006, would mean that because that value is less than our significance level of 10%, we can reject the null and prove that at least one of the independent variables significantly impacts graduation rate. And then from there we can see which specific variables has a significant impact on graduation rate.
The map in this dashboard showcases graduation rates across geographic regions in the United States for both private and public institutions. When hovering over each state, it will show the graduation rate for that state, the number of applicants, and the graduation rate based on the type of urbanization. In addition, by clicking on the state, it will link to the scatter plot down below that shows the relationship between the graduation rate and the percent of freshmen receiving federal grant aid. All universities from that state will be highlighted in the scatter plot, and a new trend line will form according to the result. Lastly, from the scatter plot visual, we found that universities with a high percent of freshmen receiving federal grant aid tend to have a low graduation rate. In this dashboard, we use the scatter plot to illustrate the relationship between the graduation rate for a 4-year student with a bachelor's degree and their average yearly tuition. When a user hovers over each dot, it will show the name of that university, their graduation rate, the type of institution, and the type of urban area that they are located in. On top of that, we created two bar graphs comparing the graduation rates based on the type of urbanization and comparing graduation rates between public and private institutions. When users hover over each category in the bar graph, it will highlight all the universities in the scatter plot corresponding to the catalog. Based on the scatter plot, we found that universities with high average tuition tend to have a higher graduation rate.
As for recommendations, there are a couple ways in making our model a little bit more reliable and accurate. One could be including other relevant data, so adding variables such as student faculty ratio, average SAT scores, or even high school GPA. Then we can test and see if these variables do significantly impact graduation rate and just ultimately make our model more reliable. Another way is fixing our multicollinearity between average tuition and public versus private schools. So both factors are relevant and significant. However, if we exclude one or combine them together, it might make our model a little bit more accurate.
Finally, key takeaways. We found that private schools have a higher graduation rate than public schools based on a 4-year bachelor degree. Also, mid-sized suburban locations have the highest graduation rate, while fringe towns have the lowest graduation rate. In addition, major cities that offer more financial aid have higher graduation rates on average. Thank you for your listening. We hope you enjoyed